So we're talking about Bronsted-Lowry acids and bases. A Bronsted-Lowry acid donates an H plus in the forward reaction, and a Bronsted-Lowry base accepts the H plus in a forward reaction. In the reverse reaction, we can find our conjugate acids and conjugate bases. So a conjugate acid donates an H plus in the reverse reaction, and a conjugate base accepts the H plus in the reverse reaction. An example reaction we have is HClO2 plus H2O makes ClO2 minus plus H3O plus. So when we're trying to identify the acids and the bases in this reaction, we have to look at which one accepts the H plus and which one donates the H plus. So in the forward reaction, HClO2 becomes ClO2 minus. It's donating the H plus, so it's our acid. H2O becomes H3O plus. It's accepting the H plus, so it's our base. In the reverse reaction, we have ClO2 minus becomes HClO2. It's accepting the H plus, so it's our conjugate acid, or conjugate base. And H3O plus becomes H2O. It's donating the H plus, so it's our conjugate acid. Conjugate pairs. So it's an acid with its conjugate base, or a base with its conjugate acid. When we look at our example reaction again, we have HClO2, the acid, with its conjugate pair ClO2 minus, because it's the conjugate base. And then we have H2O, the base, with its conjugate pair H3O plus, because it's the conjugate acid. So when we're trying to identify conjugate pairs, we have to look at whether they are accepting or donating the H plus. So here we have the acid HPO42 minus, and we know that this is going to accept or donate the H plus, and the conjugate base is going to accept the H plus. So HPO42 minus, when it donates the H plus, it becomes PO43 minus, and in the reverse reaction this is going to accept the H plus, so it's our conjugate base. Same thing with NH4 plus. In the forward reaction, the NH4 plus donates an H plus, so it becomes NH3, and in the reverse reaction it's going to accept the H plus, so it's our conjugate base. When we have a base, we know that it is going to accept the H plus, so our conjugate acid is going to be H2S, because in the reverse reaction it's going to donate an H plus to become HS minus, and NO2 minus is going to become HNO2, because the conjugate acid is going to donate this H to become NO2 minus in the reverse reaction. Another example problem we have is NH3 plus H2O makes NH4 plus OH minus. And this would be a good time to pause the video and see if you can identify the acids, the bases, the conjugate base, the conjugate acid, and the conjugate pairs. So the answers for this reaction, NH3 becomes NH4 plus. It's accepting the H plus, so it's our base. H2O becomes OH minus. It's donating an H, so it becomes our acid. NH4 plus in the reverse reaction becomes NH3. It is donating the H plus, so it's our conjugate acid. OH minus is accepting the H plus in the reverse reaction, so it's our conjugate base. So for conjugate pairs, we have our base with the conjugate acid, so NH3 and NH4 plus are conjugate pairs, and then we have the acid with its conjugate base, and that's conjugate pair, so H2O and OH minus are conjugate pairs. And then we have more practice down here with identifying the conjugate bases and conjugate acids. So this would be another good time to pause the video and see if you can find the conjugate base of HF and the conjugate acid of ClO4-. So the answer for this one, we have HF, and we know the conjugate base is going to be the acid without the H, because in the reverse reaction it's going to accept the H. So we have F- for a conjugate base. And then over here, our conjugate acid, it's going to be HClO4. And this is because it's going to donate that H in the reverse reaction to make ClO4-. So that's a summary of Bronsted-Lowry acids and bases, and I hope that helped.